So polar oceans, light limitation, tropical oceans, nutrient limitation, except in the upwelling regions like the equatorial ocean, coastal ocean, and the coral recycling system. What happens in temperate ocean productivity? So here is this beautiful picture which has a long story that you must understand. So look at the time of the year. Again, we are in the northern hemisphere. So you have where is the solar sunlight is in this yellow line. Okay, so I have a reflection I cannot see very well. So yellow line, low sunlight in the temperate oceans during winter months because sun is to the south of the equator. And as spring arrives, the sunlight begins to increase. So same idea as before as the polar oceans, but slightly different because there is a thermocline in the temperate oceans. Except during fall winter months, the surface is cooler, so the mixed layer near the surface, remember the turbulent mixing that causes uniform temperature, salinity, and density, is deeper. Thermocline is stronger, so there is some mixing of nutrients, and sunlight increases, you get a phytoplankton bloom in spring months, right? As soon as sunlight begins to increase from crossing of the equator by the sun after the spring equinox, phytoplankton begin to bloom, right? Because they have enough nutrients, they have enough light, and just like the polar oceans, the zooplankton begin to respond to the phytoplankton bloom with a delay. So far so good, very similar to the polar oceans. So the phytoplankton are grazed down. Phytoplankton, the zooplankton peak is a little bit later, and they also die away because the food dies away. And then peak summer months, actually the productivity is actually lower even though the light may be higher because nutrients got used up and primary production got grazed down. But something magical happens. As sunlight begins to decrease, as the sun is traversing back across the equator to the south, in the fall months, what happens? The cooling begins again because the sunlight is decreasing, which means the mix layer is going to become deeper again. Heavier water is going to mix into the colder water below, and the thermocline is going to start becoming sharper, but the deepening of the mix layer is going to chew into the nutrients which are more in concentration below the surface. Remember the nutrient profile. So you have to combine the radiation forcing of the surface mix layer with the nutrient profile and see that nutrients are being mixed into the euphoric zone. So you get a second bloom. It's called a fall bloom. So you have a spring bloom and the spring zooplankton response, which is very similar to the polar ocean. Except that unlike the polar ocean, in the temperate ocean you still have enough light in fall season as the sun is going south, causing the cooling and the mixing and the nutrient entrainment, it's called entrainment from below into the euphoric zone, producing the second fall bloom and a second zooplankton bloom, which are smaller than the spring blooms because the nutrients are not that high as from the winter mixing. Okay, so you can see the nutrient profiles here, high during the winter months, used up by the photosynthesis in the spring months, reach their minimum in the summer months, begin to build up as the cooling of the fall sun's return deepens the mix layer, and then they begin to build up again in the winter months. So this is a very nice combination of seasonality, physics, and biology, nutrient profiles, and so on. So temperate ocean productivity is highly seasonal. It has a winter low. Many nutrients are available, but sunlight is not enough. Spring bloom is high, the strongest bloom of the year. Summer is got a few nutrients, high light, but no production because nutrients are too low. And in the fall you get a secondary bloom, it's called the fall bloom. So here is the cartoon of that. In the winter you have near isothermal mixing during fall winter, which is mixing up nutrients. Spring comes, light becomes available, water column gets stratified, so it traps the nutrients in a shallower layer and light becomes sufficient. So you have to understand this part. When you form a stratification, nutrient concentration is high and it's trapped into a shallow layer now where light is enough to produce phytoplankton. So the green are the phytoplankton, blue are the zooplankton. And summer is minimal, and then fall again you get restratification or the deepening of the mixed layer and the secondary bloom that's not as strong as the primary spring bloom. So mid-latitude temperate oceans, mid-latitude oceans have a very nice seasonality. This is what you have to remember. Polar oceans, high productivity but very seasonal in spring. Tropical oceans, throughout the year some productivity but very low. Temperate oceans, seasonal productivity that's very high in spring and second peak second peak in the fall.